Okay, I've covered static nested classes and inner classes. It's time to talk about local classes. Local classes are inner classes, but declared directly in a code block, usually a method body. Because of that, they don't have access modifiers and are only accessible in that method body while it's executing. Like an inner class, they have access to all fields and methods on the enclosing class. They can also access local variables and method arguments that are final or effectively final. I'll be explaining what that means a little later. Let's review this in code. Let's have a little fun with this new type of nested class. When I was a kid, we spoke in a code called Pig Latin, so I want to create a method that creates a special class of store employee. This employee will include a special Pig Latin name, and I'll then sort on that. For those who don't know, Pig Latin strips off the first letter and tacks it onto the end of the name or word and adds the letters A and Y. So my name, Tim, would become Mte and Jane would become Anij, for example. Although this is a contrived example, I want you to imagine that there might be times where you have access to data but want to create a computed attribute or perform a specialized operation of your own. This is one way to do it. Later, when I get to streams, you'll learn more elegant and easier ways to achieve this. But for now, let's see what this looks like with what we have learned so far in the course. I'll create a new static method on the main class called add pig Latin name that will accept a list. Hopefully, you'll remember that is a generics wildcard that specifies an upper bound for this method parameters type argument. This means this method will only accept a list containing store employees or any subtype of store employee. Next, I'm going to declare the local class right here inside the method block. I'll name this local class decorated employee. Notice there's no modifiers. In fact, if I tried to use any here, I'd get a compiler error. I'll try to make this class public. You can see doing that gives me a compiler error. I'll undo that. Like any class, I can still extend another class as I'm showing here by extending the store employee class. I can also add attributes, which I'll do now. I'm making these private. However, the enclosing code in this method can still access this class's private fields even after this class declaration's closing bracket. First, I have the field that will hold the pig Latin name and another field that gets assigned the original store employee instance. I now want to include a constructor. I'll generate that, and for this constructor, I only want these two additional fields, not the store employee fields. I need to select the noargs constructor first to see the two fields in this class. Okay, so next, I want to include the toString method. I'll replace that super.toString. Here I really want to return the store employee's string representation by calling its toString method and appending this additional field, pig Latin name. You can see I've created an entire class all within my method body. This feels like a strange thing to do, doesn't it? Why would you want a class in a method? Well, it's possible, even probable, that you really just want the ability to create a class for just a single purpose. In this case, the only purpose of this class is to add a derived field, the pig Latin name, to an existing set of instances of store employees. I don't want to reinvent the wheel or add this class to my library of classes. I don't want anyone else to use it or extend it. I only want it to exist for this one specific purpose. Okay, so now that I have this class, I want to create a list of these decorated employee types and print them out. I'm going to do this in this same method directly after the class declaration I just added. First, I'll create a new list of decorated employees. I'll pass the size of the list as the initial capacity. I'll then loop through the list that was passed to this method, which is my list of store employees, and I'll set up instances of the new type of employee, adding them to my new list. This code sets up a list of my local class, the decorated employee, which you can think of, as a wrapper class to the store employee with one additional field. This code shows how the pig Latin name is derived. The first character is removed with the substring method starting with 1 as the index, and that first character is then retrieved with charat and 0 as the index and appended. Finally, I end with A and Y tacked onto that. I'll print out each of my decorated employees with an enhanced for loop. Okay, so that's the entire method. I want to execute this from the main method. First, I'll print out a title Then I'll call the method. I'll run this now. You can see my calculated pig Latin name printed out for each employee, OMTE, UD, BAE, and so on. But let's sort by this name now. How would I go about doing that? You might say comparator, since we've spent so much time with that interface, but this time I'm going to have this local class implement comparable. These local classes can implement interfaces, just like any other class. I'll go back to this class and add implements comparable and make the type argument equal to this new class decorated employee. Again, I want to type the comparable interface with my decorated employee so that my compare_to method compares these specific types. This means I can use the pig Latin name directly in this method without casting. IntelliJ prompts me to implement the method, so I'll do that. Here I want to compare the pig Latin names on the current instance with the one passed to it. Finally, I want to make a call to sort my list of decorated employee before I print them out. Remember, if I pass null to the sort method on a list, it will use the comparables compare_to method. This is the same as if I had passed the result of the comparator.naturalOrder method to sort. Running that now. You can see that store employees have been sorted by the pig Latin names in alphabetical order. So Marty, whose pig Latin name is Artie May, is first. This local class decorated an existing class, meaning it added extra functionality to the class, like this new derived field, and also provided a way to sort by this new field. This class both extended a class and implemented an interface. It overrode the toString method and implemented the abstract method, compare_to. Okay, now let me show you a couple of other things about local classes. I'm first going to set up a local variable in my method and call that last name. In the local class, I'm going to use this local variable in the class constructor code. I'll add it to the end of the generated pig Latin name. I think it's pretty neat that I can use local variables in the method or even method arguments to influence whatever I want to happen in this local class. If I run this code now, you can see Piggy as the last name for these pig Latin names. Let me go down to that last for loop, and this time I'm just going to print the original name and the pig Latin name. You might be asking, why is this interesting? The answer is because here in both cases I'm accessing private attributes on the local class, the pig Latin name field and the original instance field. I'm accessing these outside of the class declaration. A method that has a local class can access any of that class's fields, private or not, on any instances used in the method. You may also be wondering why I'm using getName on the original instance and not on my decorated employee instance. Well, I never actually set name on the decorated employee instances themselves or any of the other store employee fields that were inherited. Most of these fields were private, with no getters or setters, so my class, even though it was a subtype, had no access to these fields. Finally, the last thing you need to understand is final and effectively final variables. This is because local variables can only be used in a local class if they are final or effectively final. So what does this mean? When you create an instance of a local class, referenced variables used in the class from the enclosing code are captured. This means a copy is made of them and the copy is stored with the instance. This is done because the instance is stored in a different memory area than the local variables in the method. For this reason, if a local class uses local variables or method arguments from the enclosing code, these must be final or effectively final. The code sample on this slide shows a method parameter called method argument in the doThis method declared as final, and a local variable in the method block, field30, also declared with the keyword final. In both these cases, this means you can't assign a different value once these are initialized. These are explicitly final, and as a result, any of these could be used in a local class. In addition to explicitly final variables, you can also use effectively final variables in your local class. A local variable or a method argument are effectively final if a value is assigned to them and then never changed after that. Effectively final variables can be used in a local class. In my code, I can use last name in my local class's constructor because I assigned it a value and never changed it. But what if I assign it a different value, let's say at the end of the method? That gives me a compiler error above this code. on line 67, where I use the last name local variable in the constructor of my local class. If I hover over that error, IntelliJ tells me last name needs to be final or effectively final. Because I made changes to the value of that variable in the method, even after the class declaration, this means the variable isn't effectively final, and for that reason I can't use it in my class. I'll undo that so that the code compiles. You may have noticed that IntelliJ has been giving us some warnings or indication for some of our fields and variables that they might be final. I'll be talking more about when to use final and when not to when I review the final modifier in an upcoming section. For local classes, it's just important to recognise when a variable is not final or effectively final, because you can't use it in the local class directly, as I've demonstrated here. Before I end this video, I want to point out that as of JDK 16, you can also create a local record interface and enum type in your method block. These are all implicitly static types and therefore aren't inner classes or types, but static nested types. The record was introduced in JDK 16. Prior to that release, there was no support for a local interface or enum in a method block. You may see older tutorials saying you can't do this, but just know that this functionality is now available. I'll be demonstrating an example of this later in the course. In the next video, I'm going to look at the last nested class type, the anonymous class, which is a special kind of inner class. I'll see you in that next video.